to Beyond the Grades. In our previous episode, we discussed a question that every parent asks at some point. What kind of children do we hope to raise? We talked about qualities like independence, resilience, curiosity, and the ability to continue learning. We believe these qualities are much more important than simply getting good grades. Today's conversation is really a continuation of that discussion. If we already know the kind of learner we hope our children will become, the next question is, how does that journey begin? Over the years, we've had the privilege of teaching many students who eventually studied several years ahead of their school grade. Naturally, people often ask us, were these children simply gifted? Our experience suggests something a little different. Many of these students develop certain habits of thinking from a very young age. One of the earliest, and perhaps one of the most overlooked, is number sense. Interestingly, most parents don't come to us because they are worried about number sense. They usually come because their child is struggling with word problems, fractions, or algebra. But after teaching children for many years, we've often found ourselves asking a different question. Did the difficulty really begin there, or did it begin much earlier? Anna, what do you think?
Yeah, I think that's a very interesting question because in my experience, parents usually don't become worried during the early years. A child may be able to do simple addition and subtraction quite well. They memorize their multiplication tables. Everything seems to be progressing normally. Then suddenly, in primary 4 or primary 5, word problems become difficult. Or later, in secondary school, algebra becomes a real challenge. That's often the point where parents start looking for help. But when we work backwards, we sometimes realize that the difficulty don't actually begin there.
I completely agree. One thing I've noticed is that mathematics changes as children move through school. In the early years, mathematics seems to be about calculation. Can you add? Can you subtract? Can you multiply? But as children grow older, mathematics gradually becomes less about calculation and much more about understanding relationships. In word problems, children need to understand how quantities are related. In fractions, they need to understand relationships between numbers. In algebra, numbers are replaced by symbols, but students are still thinking about relationships. And the symbols become more abstract, but the thinking process is remarkably similar.
That's a really interesting point. So perhaps the challenge isn't that the mathematics suddenly becomes difficult. Perhaps the mathematics is asking children to think differently. Fen, from your experience, what do you think?
I think one of the biggest misconceptions is that if a child can calculate, then the child has a strong mathematical foundation. Calculation is certainly important, but calculation alone isn't enough. Behind every strong mathematical learner is usually a deep understanding of numbers. If children haven't developed that understanding, they often need to spend a lot of mental effort simply processing the numbers themselves. When that happens, there's much less mental capacity left for analyzing the problems, recognizing patterns, or thinking logically. That's why we sometimes see children who can complete pages of calculation confidently, yet become completely lost when they face a new type of question. The issue isn't that they suddenly forgot their mathematics. It's that the mathematical thinking required has changed.
I think that's something teachers see quite often in school as well. Two children may know their multiplication tables, but when they're given exactly the same word problem, one child immediately starts organizing the information, while the other doesn't know where to begin. The difference isn't simply calculation. It's how they understand the numbers in the question.
The same thing happens later with algebra. Many students say I was good at math until algebra. But algebra doesn't really introduce a completely new way of thinking. It simply asks students to apply the same understanding of relationships using symbols instead of numbers. And if those relationships have been built up over many years, algebra often feels much more natural.
Listening to all of you, I realized something. Perhaps parents usually notice mathematical difficulties when children reach word problems or algebra, but the foundation for dealing with those challenges may have been developing or not developing many years earlier.
Exactly. And that's why today's topic is so important. When people hear the term number sense, they often think it's only relevant for preschool children. From our experience, it's much more than that. Number sense is one of the earliest foundations of mathematical thinking. It influences how children approach calculations, word problems, fractions, algebra, and many other areas of mathematics later on.
So perhaps mathematical thinking doesn't begin with difficult mathematics. Perhaps it begins with something much simpler. It begins with understanding numbers. In the next part of today's discussion, we would like to share something we found fascinating over the years. Parents often ask us, how do you know whether a child has a good number sense? Interestingly, we usually don't need difficult tests. Being a Kumon instructor, we don't only look at whether children get the answers right. We are constantly observing how they think. Sometimes very simple worksheets tells us much more than difficult questions. Today we would like to share 4 examples. Let's begin with one of our early level 5A worksheets. At first glance, it looks very simple. The child is simply connecting numbers from 36 to 47. Many parents might look at this page and think, this is just number recognition. Anna, what do you actually observe?
Interestingly, I'm not really looking at whether the child can recognize the numbers. I'm observing something much deeper. Does the child already have an internal number line? Some preschool children complete this worksheet almost effortlessly. They don't search for every number. They already know that after 39 comes 40, then 41, then 42. It's almost as though they can already picture the sequence in their minds.
Yes, but other children approach exactly the same worksheet very differently. They find 36, then they stop and search for 37, then they stop again. Every number is a separate task. That doesn't mean they can't learn it. It simply tells us that their understanding of number sequence is still developing. The worksheet is the same, but the thinking behind it is completely different.
That's why these early worksheets are much more important than they appear. They are helping us observe whether children are beginning to organize numbers naturally in their minds. Over the years, we have noticed that children who can comfortably complete worksheets like this during the preschool years often develop a much smoother mathematical journey later on.
Here's another worksheet that often surprises parents. Questions like 99 plus 1, 199 plus 1, 499 plus 1, 999 plus 1. Some parents ask, why are we introducing such large numbers to young children?
What's fascinating is that children with stronger number sense usually don't see 6 different questions. They see one idea. If 99 becomes 100, then 199 becomes 200. 999 becomes 1000. The same pattern continues. They are beginning to understand how our base 10 number system works.
Exactly. This worksheet isn't really about addition. It's helping us observe whether children understand place value. Can they comfortably move from 2-digit numbers to 3-digit numbers? Do bigger numbers make them nervous? Or do they simply see the same pattern continuing? One thing we have noticed is that children who become comfortable with larger numbers at an early stage usually approach later mathematics with much greater confidence.
Now let's look at a worksheet from level A. Many parents see a page of addition questions. What do we see?
I see opportunities to observe whether children connect ideas. For example, 17 plus 8, 27 plus 8. A child with stronger number sense often doesn't start the second question from the beginning. Instead, the child thinks, if the first number increased by 10, then the answer should also increase by 10. They are noticing relationships.
Yes, the same thing happens with questions like 12 plus 10, 22 plus 10, 22 plus 11. Children with stronger number sense naturally ask themselves, what's changed? What stayed the same? They don't treat every question as a completely new problem.
This is something we have observed again and again over many years. Stronger learners don't necessarily solve more questions. They see fewer mathematical ideas. Many questions are simply different versions of the same relationship. That's one reason their learning becomes increasingly efficient. They are not memorizing more, they are recognizing more.
Finally, let's look at the worksheet from level B. This page includes ordering numbers, filling in missing numbers, and completing number patterns. Again, many parents simply see different exercises.
Yes, when I look at this worksheet, I'm asking different questions. Can a child compare numbers? Can a child organize them from smallest to largest? Can a child predict what comes next? These are all important parts of number sense.
One of my favorite sections is the number pattern. Some children simply memorize 2, 4, 6, 8. Others suddenly realize, oh, we're adding 2 every time. That moment is very important. The child has stopped memorizing numbers and started recognizing a mathematical rule.
Listening to these 4 worksheets, one thing really stands out to me. Parents often see 4 pages of simple mathematics. As Kumar instructors, we see 4 windows into a child's mathematical thinking. Every worksheet tells us something. Is the child beginning to organize numbers? Can the child recognize relationships? Can the child predict patterns? Can the child connect today's learning with yesterday's? Those observations help us understand not only what children know, but also how they think.
That also explains another question parents ask us quite often. Why does Kumon place so much emphasis on mental calculation?
Yeah, many people think it's simply because Kumon wants children to calculate quickly. Actually, speed is only a byproduct. Over many years, we have had the privilege of teaching students who eventually study 5, 6, or even more years ahead of school. When we look back at those students, we noticed something interesting. Again and again, they share similar habits. They enjoy working with larger numbers. They naturally searched for patterns. They looked for more efficient methods. When reducing fractions, they often recognized the greatest common factor immediately. When finding common denominators, they mentally recognized the least common multiple instead of listing multiples one by one. They constantly ask themselves, is there a better way? These weren't habits that Kumar invented. They were habits we repeatedly observed in mathematically strong learners that made us ask an important questions. Can these habits be developed in many more children? We believe they can. That's one of the reasons Kumon places such a strong emphasis on number sense and mental calculation. Not because fast calculation is the goal, but because efficient thinking is.
I really like that distinction. We are not trying to help children become faster calculators. We're helping them become better mathematical thinkers. In the final part of today's discussion, we would like to talk about something every parent can do. How can we support the development of number sense at home? After listening to these examples, many parents might be thinking, in everyday life, let's share a few ideas that we have found helpful over the years.
The first suggestion is actually very simple. Before children become confident calculating with numbers, they first need to become comfortable living with numbers. Read numbers together. Write numbers together. Recite numbers beyond 100, then beyond 1000. Many parents become worried when they see large numbers. Interestingly, children often aren't afraid of big numbers unless adults teach them to be. The more familiar children become with numbers, the more naturally they begin to understand them. That's exactly what our early worksheets are helping children to develop.
Yes, numbers are everywhere. Read bus numbers, house numbers, price tags in the supermarket, car park numbers, lift numbers, calendar dates, clock times. These small conversations help children realize that numbers are part of everyday life, not something that only exists on worksheets.
Earlier, we talked about children recognizing patterns instead of treating every question as something new. How can parents encourage that?
Sometimes the simplest change is changing the questions we ask. Instead of asking what's the answer, try asking what do you notice? What's different? What's the same? What do you think will happen next? Those questions encourage children to observe relationships rather than simply memorizing answers.
For example, instead of asking, what's 199 plus 1? You might ask, what do you think will happen when we add 1? Very often, children discover the pattern themselves. And when children discover a pattern on their own, they usually remember it much longer than if someone simply tells them the answer.
Another thing we noticed from those worksheets was that stronger learners naturally connect ideas.
Oh, exactly. When children finish one question, instead of immediately moving to the next one, we can ask, does this remind you of another question? What's similar? What's changed? For example, after solving 17 plus 8, ask, what do you think will happen if we change 17 to 27? These conversations help children transfer what they already know instead of starting from the beginning every time.
That's one of the biggest differences we observe. Mathematics gradually becomes one connected system instead of hundreds of separate topics, and that makes future learning much easier.
Perhaps this is the hardest suggestion for parents. When children hesitate, our natural instinct is to explain.
I completely understand that feeling. But over the years, one thing has become very clear to us. Many mathematically strong learners weren't the children who received the most explanations. They were often the children who were given opportunities to observe, think, make mistakes, and discover relationships for themselves. That's one reason Kumar encourages daily practice. The worksheets isn't simply there to get the correct answer. It's there to give children repeated opportunities to discover mathematical relationships independently. Learning mathematics is very much like learning to ride a bicycle. We can explain balance, we can demonstrate, but eventually children have to experience it for themselves. Number sense develops in exactly the same way.
Before we finish today's episode, I'd like to go back to the questions we asked in our previous episode. What kind of children do we hope to raise? Today we've taken one small step towards answering another question. How does mathematical thinking begin? Looking back at our 4 worksheets we discussed today, many parents may simply see 4 pages of early mathematics. As common instructors, we see something different. We see children learning to organize numbers, to recognize relationships, to notice patterns, to search for more efficient ways of thinking. Those habits don't appear overnight. They grow gradually through daily practice, careful observations, and meaningful discovery. Perhaps that's why Kumar places so much emphasis on what seems to be very simple worksheet. We are not only thinking about today's mathematics, we are thinking about the mathematics children will be learning 5 years from now, 10 years from now, and even beyond school. Because today's number sense becomes tomorrow's mathematical thinking. The encouraging news is that we don't believe these habits belong only to gifted children. With the right environment, consistent daily practice, and patient guidance, we believe many children can gradually develop them. Before we go, we'd like to leave you with one final thought. Today, we talked about number sense, one of the earliest foundations of mathematical thinking. but mathematics isn't the only subject where strong foundations matter. In language learning, we've observed something very similar. Many parents only become concerned when children struggle with comprehension, vocabulary, or composition. But just like mathematics, those difficulties often begin much earlier. So in our next episode, we will explore another hidden foundation behind strong learners. Early language input and why reading matters long before children are expected to read independently. We'll discuss why exposure to language is just as important as number sense is to mathematics, and how these early experiences shape children's ability to think, understand, and communicate. We hope you join us for that conversation. Till next time, let's continue looking beyond the grades.